Welcome to this concept explainer brought to you by CBSE ScoreLab of ProfSam.com. That is ProfSam.com lad.
Hello, everyone.
Today, we are undertaking a deep dive into the fascinating topic of polarization. It's the final section of Unit 10, Wave Optics.
And it can be a bit tricky.
It can, but our mission is to explain this so simply that you'll understand the concept, lose all fear, and be completely ready for your board exams.
Sounds good.
Okay, so let's unpack this. Have you ever wondered how 3D movies actually work? You know, where you wear those special glasses and suddenly see all this depth?
Oh, yes, or even those fancy sunglasses.
Exactly. Why can some sunglasses completely cut out the glare from a wet road, but normal tinted ones just can't?
Yes, the anti-glare ones. It's amazing. The light is still there all around you, but that blinding reflection just disappears.
Yeah.
How does light know which part to block?
Well, this is where it gets really interesting. It happens because light is a transverse electromagnetic wave, and its ability to act in a specific direction, which we call polarization, that is the key.
So it's all about direction.
It is. We are going to see how light can be organized in such a way that technology like, say, LCD screens and even certain medical analyses become possible.
Okay, I'm ready.
The core idea is very simple, really. Light waves travel forward, but their electric field, the oscillation, vibrates perpendicular to that direction.
Perpendicular. Okay.
Now, unpolarized light vibrates randomly in all perpendicular directions at the same time. It's a mess.
So it's completely chaotic.
Yes. And polarized light is just light that has been forced to oscillate in one specific direction only.
So it's organized.
Exactly. Let's use an analogy. Imagine you are holding a long rope that passes through a thin vertical slit in a fence.
Okay.
If you shake the rope up and down a vertical oscillation, the wave passes easily through that vertical slit, right?
Right, it would go straight through.
But what if you shake the rope side to side? A horizontal oscillation.
The wave would hit the fence, it would be blocked.
It's blocked. That vertical slit is our polarizer. It only lets the oscillation component that is parallel to the slit, its pass axis, to pass through.
So if the light from the sun is oscillating randomly in all directions,
It's like you're shaking that rope in every direction at once.
and the polarizer only allows, say, the vertical part to get through.
Exactly. Mentally picture it like this. Unpolarized light is a messy, rapidly changing vector pointing everywhere perpendicular to its travel direction.
Okay, a chaotic bundle of arrows.
Yes. When it hits the polarizer, the resulting wave is now a clean vector, only oscillating, let's say, vertically. That is what we call linearly polarized light.
Clean and simple.
Now let us see how NSERT defines this and what happens when we use two of these polarizers. First, let's confirm the wave type. What does our source material say about the nature of light waves?
Okay, reading from the source.
Sure.
Since the displacement, which is along the IK direction, is at right angles to the direction of propagation of the wave, we have what is known as a transverse wave. Also, since the displacement is in the A direction, it is often referred to as a I-polarized wave. Further, the string always remains confined to its xi plane, and therefore it is also referred to as a plane-polarized wave.
Very good. So light is a transverse wave. That's the main takeaway. The oscillation is perpendicular to the travel direction.
Right.
Now, when unpolarized light of some initial intensity, let's call it I naught, passes through the first polarizer, statistically, half the electric field components get absorbed and half are transmitted.
So the intensity is cut in half.
Immediately, the transmitted intensity is reduced by half. So I1 equals I naught divided by 2.
Always the first step.
Always. But the most crucial law for polarization is Malice's law. It governs what happens next with the second polarizer. Could you please read the exact wording of Malice's law from our source?
Yes. It says, thus, as we rotate the Polaroid P1 or P2, the intensity will vary as I equals I naught cos squared theta, where I naught is the intensity of the polarized light after passing through P1. This is known as Malice's law.
Excellent. Let's apply this with a quick, simple example to show how powerful this control is.
Okay.
Imagine we have unpolarized light. Its initial intensity is, say, 100 watts per meter squared. We use two polarizers. The first one is aligned vertically. The second one, the analyzer, is rotated 30 degrees from the first one.
Got it.
So step one, the unpolarized light hits the first polarizer. What happens to the intensity?
It immediately halves. So I1, the polarized light intensity, is 100 divided by 2, which is 50 watts per meter squared. And this is the I naught from Malice's law.
Perfect. Now, step 2. This 50 watts per meter squared polarized light hits the second polarizer, which is rotated by theta equals 30 degrees. We use the formula I2 equals I1 cos squared of 30 degrees.
Okay, and cos of 30 is root 3 by 2.
Correct. So we square that.
Which gives us 3 by 4.
Exactly. So I2 equals 50 times 3 by 4.
Which is 37.5 watts per meter squared, so the light gets dimmer.
As expected. Now for the most important part. Step 3, extinction. What if we rotate the second polarizer to 90 degrees?
90 degrees.
Mm-hmm.
So they're perpendicular. Crossed.
They're crossed. What's the cosine of 90 degrees?
It's 0.
So what's the final intensity, I2?
It will be 0. Complete extinction. No light passes through.
Yes. This shows that the light passing through the first polarizer is absolutely 100% oscillating in only one direction.
That's the proof.
Hope everything is clear so far. This concept explainer is from ProfSam.com. That is PROFAMM.com.
Okay.
Now, this whole phenomenon, it's fundamentally different from interference or diffraction. Polarization is what proved, historically, that light is a transverse wave.
And not a longitudinal one like sound.
Exactly. You can't filter a longitudinal wave by direction because its oscillation is in the same direction it's traveling. This vector nature is crucial because it ensures that only light waves oscillating in the same plane can interfere or diffract together.
So polarization is a prerequisite for stable interference patterns.
You could say that. It's a very important condition. Now, we must tackle some silent killers, the 3 misconceptions that frequently cost students marks in the exam, even when they know Malice's law.
I'm listening.
Wrong idea number 1. Many students think polarized light is somehow stronger or has more energy than unpolarized light.
Why would they think that?
They associate organized with powerful. It's an intuitive jump, but it's wrong.
So what's the correct idea?
The correct idea is that polarization is about organization by direction, not total power. When unpolarized light passes through a polarizer, its total intensity decreases by 50%.
Right, from I naught to I naught by 2.
It is not stronger, it is just filtered.
So the light vector is just sorted out, but half the energy actually gets blocked in the process.
Precisely. Okay, wrong idea number 2. Students believe polarizing sunglasses dim all sunlight equally.
Like normal tinted glasses.
Yes, they think it just makes everything darker, which is what normal glasses do.
But that's not right.
Not at all. The correct idea is that polarizing sunglasses are so effective because they specifically target reflected glare light from water or roads.
And that reflected light is special somehow.
It is. That reflected light is strongly polarized horizontally. The sunglasses use vertical pass axes, so they block this horizontally polarized glare almost completely.
Ah, so they selectively dim the glare, not the direct light. That's very clever.
It is. Now, the third killer idea. This one is about extinction. If 2 polarizers are crossed at 90 degrees, so you get 0 intensity,
Yes.
students sometimes think a third polarizer put somewhere else can somehow recover the blocked light. They imagine the light is just sort of paused.
Which sounds impossible.
It is. The correct idea is that once the light is fully blocked, extinction at 90 degrees, it's gone. You cannot recover it. The key learning is that extinction at 90 degrees is absolute.
It's a perfect demonstration that the light emerging from the first polarizer is truly vibrating in one plane only.
Exactly. It's the ultimate proof of linear polarization.
Got it.
You know, for some memory anchors to keep these concepts locked in your mind forever.
Great.
Remember this phrase: polarization is the direction light vibrates, cross 2 polarizers, and light dies.
Simple and to the point.
It captures the core idea and the main consequence of Malice's law. Now, for a physical gesture, we already used the rope analogy, but try this.
Okay.
Hold your hand flat, palm facing out, fingers pointing up. This is the polarizer. Now waggle your other finger randomly. That's unpolarized light.
Right.
Push your waggle through your flat hand. Only the up-down motion passes. This is polarization. Now try to pass that pure up-down motion through your other hand, but this time rotated 90 degrees, horizontal.
Nothing passes.
Nothing passes. That visual movement helps you remember Malice's law and extinction.
That's actually very helpful.
Okay, to summarize the key exam-safe points about polarization. Number 1.
What?
Polarization proves light is a transverse wave. This means its oscillation direction is perpendicular to its propagation direction.
Okay, transverse wave. Got it.
Second, an ideal polarizer reduces the intensity of incident unpolarized light by half, and it converts it into linearly polarized light.
Half intensity.
And third, when that linearly polarized light passes through a second polarizer, The intensity is governed by Melis's law, which is I equals I naught cos squared theta. This results in extinction when the polarizers are crossed at 90 degrees.
Melis's law. Perfect.
To get maximum marks in 12th CBSE physics, chemistry, and maths, visit ProfSam.com.
That is PROFSAM, right?
Yes, PROFSAM.com. Keep practicing these concepts and remember the connections between polarization and things like coherence. Good luck with your studies.
See you in the next deep dive.